Thank you. All right. So welcome everyone to week two. So the main plan for today is to quickly review the first quiz that we had in case there are doubts about any of those questions, and also then briefly talk about this week's materials, right? The first question was, what do we know about an algorithm, right? Hopefully you all have the answers now. Um, so I hope the answers make sense. Let's quickly just make sure why we think that only these two options are correct, right? So firstly, I mean, an algorithm, when you write it down, I mean, it's just some finite sequence of instructions, right? Those instructions don't have to be written in Python. What we saw in the first lecture, for example, was just writing those instructions in words, right? When we want to execute this on a computer, then the computer has to be able to understand those instructions. Then we have to write it in some programming language, and Python could be one of those options, right? But they don't have to be written in Python. Okay. Um, Now, it's important to remember that even though we write a finite sequence of instructions, right, some of those can be executed more than once. And we saw the examples even with the is prime, right? So the two main ways in which we end up repeating instructions more than once, even though we write them, in some finite sequence, right? The two main ways is one is we can do some instructions again and again and again, right? And we saw this even in the prime number examples, right? So we try something for all options from all numbers x from 2 to some n minus 1 or something like that, right? And we do certain operations again and again. We check for divisibility. So we call this a loop, right? There was a question by Radha. You had your hand raised. If you have a question, if you can just type it in the chat, then we can get to it, right? So one way is we can repeat some instructions by doing some certain things again and again in a loop. And in that case, some instructions can get executed more than once, right? The other way you can end up doing some instructions more than once, right? And we will see this in later lectures, although it was hinted at even in this lecture is, right? You are doing some main algorithm. So you've written some instructions here, right? And then there is like a helper algorithm that does some part of the task, right? So at some point in the main algorithm, you decide, oh, I need to do that other piece for which I already have an algorithm. So you kind of call that helper, right? And that helper does its job. And then we come back to this algorithm, right? And then we continue doing this. And then at some point, we call that same helper again, right? So you see, these instructions can get executed more than once. And then later, this helper comes back and we continue, right? So these are the two main ways in which we can end up repeating instructions, certain instructions more than once. So the helper algorithm might do its task more than once. It may be called to do its magic more than once. And then the other thing, as we said, is the loop, right? Certain instructions may get repeated more than once, right? So I hope it's clear that the only correct options were these ones, right? Right. Again, if you have any doubts about any of these, we can also come back. I have labeled each slide. You can tell me I had a doubt about question one, and we can come back to question one, right? So some instructions can be repeated more than once, but of course you cannot execute some instructions infinitely often. If you execute instructions infinitely often, that means you are not finishing, right? And then it won't be an algorithm. The whole algorithm has to be end in some finite number of steps, right? Otherwise, it's not an algorithm. Okay, the second question was talking about this difference between data-centric approaches and algorithm-centric approaches. So we said, okay, for which of these problems would you use a data-centric approach, right? And this business of looking at handwritten digits and trying to figure them out, this was, by the way, the first sort of big success story. So at some point you can go look up, there's this data set, which is one of the most popular data sets in machine learning. It's called the MNIST data set, right? And this is all about handwritten digits, right? And this is, when you get started in machine learning, you often do something like this, right? So this is an example where, having collected lots of data, you can come up with this algorithm to recognize when something is a 5, when something is a 3, and so on, right? So this business of recognizing from a handwritten digits are whether it's an Aadhaar number, this would be a classic case of where you would use a data-centric approach, right? But if I give you an integer and I tell you, look, this is this particular integer, tell me, is it an Aadhaar number or not, right? There are some rules for what an Aadhaar number should be, like how many digits it should have, and so on, right? Now, we may not know all the rules about what those are, but some set of rules exists. And so somebody can determine if something is a legal Aadhaar number or not, right? You could look up in a database of assigned Aadhaar numbers, is this one of those? So there is some algorithm for doing that. So there you wouldn't use a data-centric approach. You would just use an algorithm-centric approach. There is some step-by-step process for figuring out if something is an Aadhaar number or not, right? So I want all of us to be clear about these two general strategies. You can solve a problem using a data-centric approach. You can solve a problem using an algorithm-centric approach. For some problems, one of these strategies makes much more sense. So between these two, it makes much more sense to use a data-centric approach for handwritten character recognition. There isn't a simple step-by-step process to say, oh, this particular sequence of pixels is actually a 1, and this other sequence of pixels is a 7. It's much better to use data, right? Like data sets like this to recognize those, right? Similarly for words, right? If I give you two sentences and I say, do they have the same number of words? What exactly do I mean by words when I give you a sentence? How do you split them into words? That is some sequence of rules, some operations. And there it would make much more sense to use an algorithm. But if I give you two sentences and I want to know, do they mean the same thing? That you would probably need to use a data-centric approach, right? So that is where a data-centric approach makes much more sense for option 4, but not so much for option 3, right? Um, there's a question from Sarthak about, is it possible to use GitHub Copilot without installing Visual Studio Code? Yes, you can do these things, but this you'll have to sort of look up on your own. We are suggesting certain resources. Beyond that, lots of other options are available. For example, if you have a GitHub account of your own, you can access something like ChatGPT. It's called Copilot, I think, inside GitHub. This is possible to do, but again, we're not providing all the possible resources. If you're not taking the ones that we're suggesting, then we would request you to look these up on your own, or you can post a question on the forum, and then maybe somebody else who's trying these out can give you some suggestions, right? Okay, so I hope this idea makes sense. I'll just say a little bit more than is there in the lectures about sentences having the same meaning. Again, I know some of you are interested in computing much beyond this course. So just to share with you, you might know of, or you might not about this benchmark called the MTEB, right, or MTEB, right, the massive text embedding benchmark. So if you want to solve this problem, right, if I give you two sentences, do they have the same meaning? One of the ways you can try and solve this problem is by taking those sentences and running it through one of these special models called an embedding model, right? And this benchmark and this Hugging Face repository has lots of models for doing this, right? This is the performance. This axis is showing you the performance of these models. On the x-axis, you're seeing the various sizes of the models, and each one of these circles is one of these AI models, right? So one of the tasks over here is checking, similarity or clustering similar sentences into the same part of the embedding space. It doesn't matter if all these words don't make sense. My point is, if you wanted to solve this problem, given two sentences, determine if they have the same meaning, there are AI models for doing this, right? And how do they work? Well, they adopt a data-centric approach, right? And so there's all kinds of models, and this is a very complex diagram that is trying to say many things. For example, on the x-axis, it's talking about the size of the model. And typically, the bigger the model, the more data you need to train it properly, right? So this is very much a data-centric approach. Nobody is solving these problems these days using an algorithm-centric approach, okay? Okay. So let's see. So the difference between data-centric and algorithm-centric approach. Again, Satosh, this is explained in the lectures. If you have a specific question beyond that, I'll be happy to explain. I don't want to repeat what's there already in the lectures, right? Okay. Aditi has a very interesting question. How does it work if the languages are if the languages are different of the two sentences, right? So by the way, Aditi, this is the performance on the multi this is on the multilingual set. So these models actually handle different languages, right? So it's a great question you've asked, and I would encourage you to actually try this out. So for example, if I give you one sentence in Kannada and one sentence in Bangla, and can this check if those two sentences mean the same thing? In principle, it is possible to do this, right? So for some pairs of languages, the performance is good. For some pairs of languages, the performance is much weaker. Okay. Pratibha wants to know if we have more time for submitting assignments. Unfortunately, Pratibha, we go with the schedule that NPTEL puts out, right? So here is one thing I want everybody to keep in mind, right? This is an 8-week course, and I know some of you are interested in doing well on this course and getting a certificate, etc. That's great. But I want all of us to realize that learning this stuff deeply is going to take more time than 8 weeks. Okay, so I would really like you to use these 8 weeks to explore the set of ideas, gain some familiarity, but please keep in mind you have much more time to learn this material. So if you find these learning resources that we are putting out, the assignments, useful to your learning, and I hope you find them useful. We're spending a lot of time creating them. If you find the learning resources useful, please save them and come back to them, right? So please, the official time is whatever it is that NPTEL tells us, right? 1 week or 10 days or whatever. But please keep in mind that the learning resources are really there to help you learn. And it does, if it takes longer for you to learn over 8 weeks, please use that time. If you find this stuff useful, please go ahead and use it, right? All right. Okay. Vishwanath wants to know about some of the ethical issues associated with GenAI. We will talk about some of them. Even in the quiz, we talked about some of these things, right? Aditi had some follow-up questions about languages and derived from roots and things. Aditi, this gets into natural language processing. This is actually not my area of expertise. So there's a lot more to learn than I can share with you. If you're interested in these questions, please do look them up. This is, again, an introduction to some of these ideas, much more to explore, and lots of interesting questions such as the ones you're raising. Okay. Okay. Um, yeah, so then there's questions about, okay, this is about tokens, right? So there's this notion of tokens. Again, we will go too far into some of these. Some of these terms are familiar to some of you, but not to many of you. So many interesting questions to explore here. I wanted to share this with you first. As for those of you who don't know anything about the space, please explore from here. Those of you who know a lot about this space, I'm sure you have many more questions than we can handle. Okay. Again, some of these things I know about, some of these things I actually am not expert on. So given that we have a limited amount of time, I've just used this as an introduction to explore further. Okay, many interesting questions. Okay, question 3 was getting at this, interesting idea. Machine language is only zeros and ones. So how difficult can it be to read zeros and ones? How difficult can it be to write zeros and ones? In fact, the fact that it's only zeros and ones makes this super difficult to read and super difficult to write, right? I gave the example in the lecture where I have some simple statement. It's easy for us to read when it's expressed in a language like Python, right? But if I express it just in zeros and ones, that suddenly becomes very hard to read. And this is why nobody writes in machine language, right? Assembly language is a little bit easier than machine language to read, but it's still super hard. And that is why most people find it difficult to read and write assembly language, right? We don't do that, right? Um, Now this option here, code written in high level must be converted to assembly language before a computer can understand it, right? This might actually seem reasonable, right? Yeah, I mean, because I have to take my high level language, convert it to assembly, and then it gets converted into machine language, right? But saying it this way is incorrect for two reasons, right? Firstly, a computer can't understand assembly language. It has to convert it into machine language. The only thing a computer can eventually understand is machine language, right? So that is point number one. Point number two is, in principle, you don't even have to convert high level language into assembly language. I will come back to this second point later, right? But for both those reasons, this option is incorrect. On the other hand, if a computer has to understand assembly language, yeah, it can't do it directly. It has to be converted into machine language before the computer can understand it, right? And that is why these are the three options that are valid over here, right? Okay. Dushmanta wants to know about the best AI tools. There's no such thing, Dushmanta, as the best AI tools. There are many, and there are changing, and there are new ones coming. So it's very hard for us to say this is the best tools that are available, right? Anil wants to know what are similar courses. Anil, right now I'm focused only on giving you the best learning opportunities in this course. Please do look around. There are many other courses that you can learn from. So please look around. I would request you to look around. Okay. Okay, let me come back to this point about computers, right? From going from high level to machine language, right? So we had this picture in the slides. I have Python. I'm converting that into assembly, and then the assembler is converting that into raw zeros and ones, and this is what the machine can understand, right? Now, pretty much every high level language, you go through assembly or something like assembly and then down to machine language, right? But in principle, you don't have to do this, right? In principle, you could go directly from here, right? Nobody does it this way because this would be there's a lot of knowledge people have built up and skills people have built up going from here to here, and it's a difficult process to go directly from high level directly to machine language. One big challenge is when I change from one machine to another machine, that thing's machine language is slightly different, right? So that becomes a big challenge, right? But in principle, you could do this. The point I would like to make through this question is that the machine can only understand zeros and ones. It cannot understand assembly language, and it cannot understand high level language directly, right? There's a question about from Santosh about exams. Please post that on the discussion forum, and someone from NPTEL can give you better response to that, right? Mrigank wants to know, is there anything more we can do from our side to boost our knowledge of GenAI along with this course, right? Again, I'm focused, Mrigank, on getting us maximum value from this course. Yes, there are many more things you can do, but those would be beyond this course. I would suggest, if you are finding this material useful, use this as a starting point. Okay. Okay. Again, please post on the chat if you would like me to go back to a previous slide. So for question 4, and then there's a whole bunch of these questions along these lines, I give you some sentence, right? And you have to tell me if that sentence is true. If it's true, does it give a reason for using GenAI to write code or against using GenAI to write code? Or it could be that the statement is wrong, and then case you have to say incorrect, right? So each of these questions had 3 choices, right? GenAI models always write correct code, right? This is not true. In fact, most statements in the world, when we say always or never, right? Most of those statements turn out to be incorrect, right? So keep that in mind as a shorthand, right? For anything that I give you, most statements like that. I mean, I'm not saying that this is always the case, right? But most statements that have always are incorrect. Most statements that have never are incorrect. You have to think about those cases where it's not true, right? So here, for example, in the video lectures, I quoted this live code bench, right? It turns out people are thinking about these all the time. And I was recently reading a paper where they say, no, there's even a better benchmark than this. There's live code bench pro, right? And here, for example, the very hard problems have only a 2.8% success rate. And this is using the best model right now, which is in GPT-5 with a high amount of thinking, right? So these are, again, coding contest problems similar to live code bench. But the difficult ones here are really, really hard, right? So here are some problems for which the AI is only producing correct answers at 2%. And these are the best models that we have right now, right? So I'm certainly going to be following this and reading more about this live code bench pro, right? right? One of the students with initials MY wants to know, can we use GenAI in website development? Yes, it's very strong in website development, although in this course we won't be talking about that, right? So you can definitely do it, at least to create a first draft of a website. Lots of people are using it, right? So Onyx wants to know, just like high-level languages are translated step by step into machine code, how does GenAI translate human language, right? Well, this is this whole generative AI pipeline. It is running some sort of a very complex algorithm that has been improved using data-centric techniques, right? So it is running some sort of code to translate your natural language into, say, Python, and then other tools can convert that into machine language, right? It's interesting. You should ask, for example, on ChatGPT, here is a problem. Can you convert it into machine language for me, right? Try it out and see what happens, right? Can you go directly from natural language to machine language, right? Satya Devi wants to know, can you suggest some tools where we can use GenAI in teaching? All right. So this is a very broad question, Satya Devi. You will have to look at what you're teaching, etc. So I can't really give you a general answer here. If you're doing teaching of programming, then hopefully you will find the kinds of tools we are using useful, right? Um, so this is this question. So GenAI will always answers correct code. No, not true. GenAI never or rarely writes correct code. Also not true. Same picture. If you look at some of the easy problems, 81% of the times GPT-5 is able to solve these. And in the live code bench website, 99 point something percent of the time for the easy problems. So again, these things can be useful. They are useful at writing code, but they are not able to solve all problems, and they are still useful for some problems, right? A student saying, sir, if you're saying, हिंदी में बोल सकते हैं क्या? हिंदी में बोल सकता हूँ, but there are a lot of people here with speaking in many different languages, right? So we have to respect the fact we have a very diverse set of students. So I can say I can speak Hindi, but then I can't speak Kannada, I can't speak Bangla, I can't speak Gujarati. There's so many languages. I'm sure there are students here, so I won't be able to cater to all these different languages, right? And if I haven't mentioned your language, I'm sorry, but there are so many languages out there, right? Um, Sai Harish wants to know why people use GenAI to teach lessons instead of reference books. So my goal is not to replace any textbook. I just want all of us as learners to be aware of the strengths and weaknesses of GenAI when it comes to programming. And I'm putting out this course because I believe now that we have GenAI, it makes our job as learners slightly different to what it used to be. Earlier, it was very important for you as a learner to learn how to write code. If you had an idea and you wanted to, if you had an algorithm in mind and you wanted to see if it's correct, you would have to write it in code before you could check to see if it really is correct, right? Unless you did a mathematical proof, which almost is, and very few people are capable of doing that because it takes a lot of mathematical maturity to do that. So the simpler way is write it in code and then check the code, right? But today, the AI can do that. If you give a clear instruction that this is what I want to do, the AI can translate that, right? So it changes how we learn, and that is why we are putting out these things. We're not doing it as a replacement to a textbook. Okay. GK Krishna wants to know. KG Krishna wants to know about how we can use GenAI in other ways. Yes, you can, in the way you're suggesting, but again, that goes beyond the scope of our particular course, right? Julian wants to know advantages of open source versus closed and proprietary models. Again, this is a very changing landscape, but roughly speaking, the best closed source models today, you will have open source models that are that good or better in a few months. That's the general trend so far, right? So if you don't like the performance of your open source model right now, wait a few months and you'll probably get one that is much better, right? Nirmal wants to know, can we use tools like Google Colab? Yes, you can. You can use any kind of Gen AI. I want you to have an experience of the various, I want you to have the experience in general of using Gen AI. If you find the Colab experience easier, please go ahead and use it, right? Dhruv Kumar is saying, is the LLM taking time to understand for studying? I'm not exactly sure, Dhruv Kumar, what you meant. If you can rephrase, maybe I can try and answer, right? Debanjan wants to know, how can we use Gen AI in education so that it's balanced? This is difficult to answer in general. Again, I'm taking an approach here. I think we can use it effectively for learning programming, and that's the approach I'm taking. I'm not sure I have like the best balance, etc. And I'm certainly sure I don't have the best balance of learning every subject, right? I don't teach every subject, so I don't know exactly, right? Johan wants to know, what is the importance of prompt engineering in Gen AI, right? It is important, but it is not a skill that all of us need to be excellent at. There is a later video where I talk about this distinction between prompt engineering and technical prompting. So if you haven't come across it yet, please wait for it. We will come back to this. So maybe hold on to that question and we can discuss it later when we discuss what I mean by technical prompting, right? Rajshekhar wants to know where Gen AI lies on the hype cycle. Again, look up other resources. Let's not get into that here. Someone had their hand up. If you can ask your question on the chat, since we're just reading questions in the chat, maybe we can do that, right? Okay, Dhruv Kumar is saying the LLM, is it taking time for studying? Is it taking time for studying it? Again, Dhruv Kumar, it's not totally clear. Maybe I do speak Hindi. If you speak Hindi also, maybe you can ask the question in Hindi, and maybe that'll be easier. It'll become clearer what you're asking. I don't have any other language we can communicate it. So I'm sorry, I'm still not able to fully understand exactly what your question is, right? Tushar wants to know, is Gen AI a bubble or booming? Difficult to answer, different definitions. Let's not get there. Here is what I can say, right? I'm not dodging the question, but here's what I can say. Is AI a bubble in every domain? Perhaps, but in some domains, certainly as far as programming is concerned, Gen AI is super useful. And in the context of programming, I would definitely consider it useful. Okay, yeah, go ahead, please. Someone had the mic open. Yeah. Okay, if you don't have a question, I'll continue on the questions of the chat. Sneha wants to know, can you suggest some free AI tools for project work? There are lots of tools, Sneha. Please look around. I don't have a general suggestion, right? Sai Harish wants to know, how can I implement Gen AI in the current use cases? Again, not really sure exactly what you mean, Sai Harish. I'm giving you some suggestions through this course. Maybe those are useful to you. Linkable wants to know, in Gen AI, should we want to learn programming at peak level, right? So again, it's difficult to say what peak level is. I would say it is useful for your learning. So this is what this course is trying to get at. Here is how you can use Gen AI to support your learning. There will be many points in this course where you will see me say, by the way, you can use Gen AI to help you learn, right? So look out for those opportunities, right? And it can help you improve, right? Julian wants to know about other types of AI, what makes them different. Julian, I won't be able to get into this for this course. Again, I would put that question into Chat GPT, for example, and it'll give you a good first answer. Okay. Um, okay. Nikunj Kumar wants to know, is there a way to stop producing sensitive information using Gen AI? Again, these are beyond the scope of this course. Again, I would suggest these are important questions, right? I'm not saying these are not important questions, but for example, if you would like to know some of the answers here, some of these questions that you're posing, if you put them into Chat GPT, you will get a good first answer, right? It may not be a great answer, it may not be the best answer, but it would give you a good first answer, right? So we'll focus on the topics here. So may I request, because there are lots of questions that I'm getting to, right, which are in general use of AI and Gen AI. So let's skip that. I want to focus on the topic that we have. Maybe I'll come back to some of the questions later. But for the general questions, I would suggest the approach that I have just mentioned. Okay. All right. For question 6, and this gets into some of the ethical issues that was raised, right? Training Gen AI models increases CO2 emissions. Yes, massively. And this is one of the reasons against using Gen AI for code writing. I mean, if you can write the code yourself rather than relying on this technology that emits a huge amount of CO2, this is something you could consider, right? So when I decided to make this course, right? This is one of the questions I had to consider, right? So, for example, I'll just share with you a small snippet of a UN report on this, right? And you can find it at this link, or you can search for UN Environment Program, the report, right? And it talks about the massive amounts of energy it takes to train an LLM, right? 300,000 kilograms of carbon dioxide emission. This is just to train, right? So this is talking about training a Gen AI model takes a huge amount of energy, right? The reason I have put out this course is it is very clear that the energy involved in training these models currently is unsustainable. At the same time, it is very clear that very smart people are working on reducing this cost, and we have been able to reduce this cost. So I believe that cutting edge, the biggest models are burning a huge amount of fossil fuels to produce this vast amounts of CO2 are being released, and that is definitely unsustainable. At the same time, very clever engineers are working to create very efficient models, and small, very efficient models could be a sustainable way of doing this. Those models, the best of those models, are comparable to some of the top ones that we are currently using. In a few years, those will be comparable. So you should be able to use efficient models, those models that don't have a massive CO2 footprint, and they will be just as effective as some of the best ones that we are using today. That is the trend. That is where I see value, and that is why I'm keen that all of us as learners get to use these models and get to see what they are. Now, the difference between this question and the next question, the next one was for using Gen AI models, right? This is sometimes called inference. So now that the model has been trained, it used this huge amount of data, it has been trained, lots of CO2 has been emitted, that's fine. But now I just simply want to use it. I'm no longer training. I'm just doing what is called inference on it. And that same UN report talks about, for example, even using these models requires quite a bit of energy. So they're quoting the study where, for example, if you were to look up, say, some fact about Python, right? If you were to use Google search, right? A regular internet search, it costs you zero point 0.3 watt hours of energy. Whereas to do the same thing using an LLM query costs you 2.9 watt hours, right? Again, this study was done some time ago. These numbers are shrinking. Nevertheless, it's very clear that searching using an LLM, coming up with an answer using an LLM can be much more expensive than just doing an internet search, right? So these are important points to keep in mind. And again, this is a reason for not using GenAI to write code. I have a doubt about how this thing works in Python, right? Should I do an internet search, or should I ask ChatGPT, right? Uh, Keep this in mind. There's massive difference in the amount of CO2 you're putting out by blindly asking ChatGPT. If you want to do even less energy than Google search, if you can ask the question in the REPL, right, then it's better to do that, because that uses even less energy. That's running on your system, right? Okay, let's see. Somebody had their mic open. If you can keep your mic closed unless you have a question. Okay, NPTEL team, can I request somebody who has their mic open, if you can keep that mic closed, they're not closing it, right? Okay, so Niloy has a question about, in question 5, it's not wrong that GenAI rarely produces right code, so why is it incorrect? So let's go back to question 5 and let's confirm this, right? So question 5 was saying, uh, question 5 was saying, okay, GenAI models rarely write correct code, right? That's not true, right? I mean, because they do sometimes write correct code. For easy problems, they're almost always correct, right? So in that sense, the option was marked as incorrect, right? Right. You can argue that what exactly do we mean by rarely? Okay, if something is producing the correct answer 99% of the time, I don't think you can say that that's rare, right? So in this case, for this data set, the performance on easy problems is 81%, but in the lecture notes, for example, that I shared with you, on a different data set, these things can solve easy problems 99% of the time, right? So in that sense, right? Okay, let's see. Okay, so again, I'm having to skip past lots of general questions because we want to focus for now on these on the quiz questions and on the specifics of our course, right? Again, I'm delighted so many of you have these general questions. Some amount I can certainly try and answer, especially if there is time towards the end, but I want to focus our time on the specifics of the course, right? Okay. So let's see. Question 8 was, okay, so Gen AI models can be trained on well-written code. This is true, right? In the initial days, Gen AI models were trained on all the code that they could easily get their hands on, and that included poorly written code. And therefore, in the early days, a lot of these code generation models would produce poor answers. Even today, sometimes AI produces answers that are not exactly wrong, but they are poor in some sense. For example, they could have some vulnerabilities, right? So security vulnerabilities, and these are very, very important. Someone was asking earlier about, can I use Gen AI to do web development? Yes, you could do a first pass, but sometimes that might produce code that has vulnerabilities, and that might not be a good idea, right? This is why if you're doing some work for some commercial product where correctness matters, we don't want vulnerabilities in the code. It's super important that you can't just use GenAI, right? Someone will still hire an expert to develop that code, or at least to review the code that somebody put out or AI put out, right? So it's important to keep in mind that people are trying to now create models that are trained on well-written code. Increasingly, people are doing this. And so today, this is an argument for using these Gen AI models. You will see examples when you use a high-quality AI system. You will see it producing very interesting code. You may not be familiar with that particular way of writing the code, but many times that way of writing the code is what a lot of professionals do. There are some examples of this even in the coming videos, right? Where I have taken screenshots from a few months ago when I was recording the videos, and there the AI was producing these really high quality suggestions. And even if we haven't seen that particular syntax, we should understand, oh, lots of professional people write the code this way, right? So this is something to keep in mind, right? Um, okay. Akshay wants to know how effectively to learn coding without Gen AI, right? Akshay, this is how we've been teaching before Gen AI. Lots of courses, even on NPTEL, you will find lots of effective courses on learning programming without Gen AI. So if you would like to learn programming without Gen AI, also there are lots of other courses to take a look at, lots of other books, and that's how we've been doing it traditionally, right? This course is in response to the Gen AI era, right? Okay, some GenAI models may have misused open source code for training. Absolutely true. And again, in the video, we talk about how, for example, GitHub Copilot has a litigation against it, right? And not just them, a lot of other people have, right? So this is important to keep in mind. This is actually a reason for not doing what we're doing, right? Uh, Again, this is a balance that I have to take as an educator. Do I want all of us as learners to be aware of this? Yes. Do I also want us to be aware that there are some gray issues around this, some ethical issues around this? Yes, right? So these things are evolving. So as I said in the video, right? Suppose it turns out that because of that particular lawsuit, right? That particular legal case, suppose GitHub Copilot is shut down. Suppose that happens, or they bankrupt them, they give them a huge penalty and they get bankrupt. Suppose that happens, right? That does not stop the fact that this kind of technology is super useful. So somebody who trains their AI model by being more careful about this, which by the way, lots of people are doing, right? Those models will be useful. And I'm fairly sure that now the latest models that GitHub trains, for example, are much more respectful of this issue, right? So you can say, oh well, people have learned how to do it, right? It doesn't excuse bad behavior, illegal behavior in the past. So the fact that this is the case is a reason for not using some of these models. And some people actually take this view. I am not going to use Gen AI to write code because of the way they have been trained, right? And this is certainly true for some models in the past because of their misuse of Gen AI. And this is a perfectly good reason for not using Gen AI to write code, right? It's a perfectly coherent argument for not using Gen AI, right? So it's keep this point in mind, right? Okay. Um, Again, a very good question from Aditi about, is there a tool that ranks well-written code? Probably, although I'm not aware of one, right? And now that you have asked this, okay, so here is the following thing that is certainly true. There are checks. There's a set of tools called linters, Linter, linters, right? That check the quality of code, right? And so you can use this to check the quality of any type of code, not just AI written code, right? And people have been sort of original linters were written, using some simple rules. Increasingly, people are using AI style linters that look at the quality of the code. Basically take this linter perspective. Is this well-written code? Is it good style? But use AI to help here. So I'm sure there are a lot of advanced linters that can do the kind of thing that you have suggested. Again, good question. Okay, coming to question 10. So there was a whole bunch of questions that really encouraged you to open up a REPL and try, right? So here, for example, I did this experiment, 5 divided by 2, true division. Is it greater than 5 floor division 2, right? So is this the case? And the REPL says yes, right? And if you're not sure why it is, again, just open up a REPL and check, right? 5 true division 2 is the floating point value 2.5, right? This expression has type float, right? This expression evaluates to 2 and it has type int, right? So now we're asking, is the floating point value 2.5 larger than the integer value 2? And the answer is yes, because 2.5 is more than 2. It's perfectly okay to compare a float and an int. Python can do that. And in this case, the answer is true, and only these two options are correct, right? So for the quizzes, please keep in mind, I want you to be able to use the resources that are available to you, right? But I have a suggestion for you. If you really want to learn this stuff, right? You can answer this question by opening up a REPL, for example, and copy pasting, typing, or whatever, looking at the answers and then marking the correct options, right? That is one way, and you will ace the quiz and you will get full marks, but you will probably learn less. So I have a suggestion for you, right? You have a way of checking your answers in NPTEL, right? So first try and answer the quiz just based on what you understood. Then do check, don't submit it, right? And see if you got anything wrong. If you got anything wrong, open up a REPL or open up Python Tutor or whatever it is that all the tools that we will be using later on. Open up those tools and check out, why is it that my understanding is wrong? Then you will understand, oh, I'm getting this misunderstanding, and that is why this I got this option wrong, right? So this is an opportunity for us to learn. Of course, sometimes we will accidentally mark something, oh, then realize, oh, that was silly, I shouldn't have done that, I should have done it that way. That will also happen. But many times if you get something wrong, um, it's because we have misunderstood some important concept. So feel free to use the tools, but don't just use them to simply give you the answer. Try and predict the answer before using the tool, right? That is what I would hope. Okay. Uh, okay. So let's see. Okay, there's a question about law, which I don't know anything about. Mrigank wants to know, after submitted my own answers, then for curiosity, I asked GPT-5 some of the questions, and I found that it all to check my answer, and then I found that all answers have matched except Q11 and Q15. Okay, so let's come to Q11 and Q15, Mrigank, and let's think about it. Interesting. I'm very glad you did the experiment. Great. Let's come back, right? And maybe if you can remember what GPT-5 said for those, then maybe we can think about those, right? But it's interesting observation. Okay. Dinesh has raised hand again. Dinesh, if you can post a question on chat, I'll try and answer it. Okay. Okay, question 11. I'm super surprised that GPT-5 got this wrong, but this is a simple thing to check in the REPL, right? For example, basically one of these produces a division by 0, and that's 2 floor division 3, right? That will produce a 0 division error because obviously we do the thing in the brackets first, and 2 floor division 3, if you try it out, is 0. So then this is doing 1 divided by 0, and that is an error, right? But none of the other things produce an error, right? So it's surprising that GPT-5 was unable to figure this out, right? I find that very surprising, but you did the experiment. Good that you did the experiment. But this one, it should have got. I'm surprised. Okay. GPT said option number 2 and 3 as the answer. So GPT-5 thought this. So, okay, here is a possibility, right? Maybe in the question you didn't say it was Python, right? There are other languages in which this will cause an error. Having said that, if you did tell it, if you copied the exact question and you told it it's Python and it got this wrong, very bad for GPT-5. Anyway, I'm focused more on what we know, not what GPT-5 knows. I hope all of us are clear why this second operation is not going to cause an error. What happens, the order of operations is we first do what's in the brackets. 2 true division 3 is 0.6666 whatever, right? And uh, one floor division, this will produce some sort of answer, right? So you should try it out in the REPL again. If we can pull up a REPL, let me just do that. Let me just stop sharing this and let me share my REPL, right? Uh, Again, you should try this out, right? One floor division, 2 divided by 3, right? It produces some answer. Right? It produces some answer. It may not be the answer you were expecting, but it does produce some answer. It doesn't produce an error, right? So maybe this was a slightly tricky one, but this is where I want you to be able to uh, guess something. I think, like, for example, suppose you thought, oh, this should produce an answer because I'm doing one floor division, a floating point number, and that really doesn't make any sense. So maybe some sort of error happens. So maybe when you were doing the NPTEL quiz, you mark that as a possible error, right? But then open up a REPL and check, right? And it produces an answer, right? It doesn't do a zero division error for sure, but maybe you thought some other error happened. No, apparently this is well defined in Python, right? So again, I hope you at least are very clear why this is not a problem. Okay, let's go back to the slides, right? Excellent, right? Okay. Okay, so question 12, the population of India is 140, between 140 and 150 crores. How many bits will this take? Either you can work it out yourself. Again, the slightly lazy way is open up the REPL and you can calculate what the bit length is, and it'll tell you it's 31 bits, right? But again, you should be clear why it's 31 bits, right? Interestingly, if you try to, by the way, one thing here to keep in mind is, right, this really is 140 crore because exponent happens before multiplication. It's higher precedence. So we do 10 to the power 7 first, right? That is 1 crore is 10 to the power 7. And then we multiply that with 140, right? So it's important to keep that in mind. Even better would have been to put extra brackets here just to be clear that I meant to do the 10 to the power 7 first, right? Obviously, if I do 140 times 10 first and then raise it to the power 7, that's a much bigger number that will require more bits, right? So 31 is the right answer, right? But interestingly, if you had done this, right, 1.4 billion, right? So 1.4 times 10 to the power 9, that actually produces an error, right? Why? Because 1.4 is a float, and with float, you can't do this bit length business, right? So interesting to keep in mind. If you ask the question using the crore notation, like something like this, or you wrote out 140 followed by the appropriate number of zeros, 7 zeros, that would have worked, right? But if you tried it with 1.4 times 10 to the power 9, it doesn't work, right? Again, because float doesn't allow this bit length, right? Sarthak wants to know, can we say that AI uses use of AI is reducing the thinking and problem solving capacity of the human, right? Certainly, there is that risk, Sarthak, and if that happens, then that's a problem. For me as an educator, for you as a learner, that's a problem. That's why we're trying to keep our mental muscles well exercised. I'm showing you places throughout the course, you will see places where the AI makes mistakes, and I'm asking us as learners to get better than the AI. Right? That is a challenge because the AI is always getting better by the looks of it. Very smart people are working on making the AI better. We have certain limits on how much we can learn, how quickly we can learn, and so on. So it's a challenging time for us as learners, right? I am deeply respectful of the fact that for you as a learner is a very challenging time. I'm an educator. I'm also a learner. I'm always learning, but it's a very challenging time, and so that's why this course. I believe it's important to have this course, right? Okay, this question hopefully was very straightforward. It is just based on what we said about what are legal strings, what are not legal strings. If you start with double quote, you must end with double quote. So that's fine. This is wrong because it starts with double quote, ends with single quote. That's not allowed in Python, right? If you start and end with a single quote, that's fine. But then inside that, you can't have a single quote, right? So that doesn't help. That doesn't work. But if you put a backslash before it, this is this escape symbol, right? So this is explained in the lecture. Again, you can try it in the REPL, that's fine. If you really want to put a single quote, you can put it inside double quotes or triple quotes, right? Which is what is here, right? Triple quotes will work also. So all these are legal options and the other ones are not. Hopefully that was fairly straightforward. Okay. Um, Here again, some of these are not obvious. For example, this last one is not obviously true. It turns out to be true, right? It turns out that the way the letters are mapped to numbers, that's what the ORD function tells you. It turns out that uppercase letters have smaller value than lowercase letters, right? This is true because obviously capital A is the same string, whether you put it in single quotes or double quotes. Python doesn't care. But Python does care about the difference between uppercase A and lowercase a. This is not true, right? They don't have the same ordinal value or numbering value, right? Similarly, the value of the letter 7 is not, the internal numbering of the letter 7, the ordinal value is not the integer 7. But the gap between upper and lowercase a is the same as the gap between upper and lowercase b, is the same as the gap between upper and lowercase c, all the way up to upper and lowercase z. They all have the same gap, right? And because of that, you can actually use this difference to convert upper and lowercase letters into each other. Later in the course, when we do the C programming language, we will actually make use of the fact that this gap is constant to convert upper and lowercase letters, right? Go from lowercase to uppercase and so on, right? So Chaitanya maybe has checked if what the gap is, it's 26. You can check in the REPL exactly what the gap is, Chaitanya. Chaitanya could be right, Chaitanya could be wrong. We don't have to trust Chaitanya. We should do the experiment. Maybe Chaitanya has done the experiment and is claiming that it's 26. But let's Chaitanya, I'm sorry, I know you're a human, but let's say Chaitanya was an LLM. Let's say Chaitanya said, oh, the answer is 26. The gap is 26, right? Are we going to blindly accept what Chaitanya said? No, we can open up the REPL and double check what Chaitanya said, right? And we do this whether it's Chaitanya or we do it whether it's an LLM, right? We can apply the same sort of double check, right? Very good. So good. Excellent. Okay, question 15. Apparently GPT-5 got this one wrong too. This one is a bit tricky, right? Especially the first option, right? So firstly, let's see why we believe this first option is false, right? 2 to the power 0.5 to the power 2. We have to remember that the way this is explained in the lecture, that actually 0.5 to the power 2 evaluates first. So 0.5 to the power 2 is half times half. So that's quarter, so 0.25. And then this is 2 to the power 0.25. And that's definitely not 2. So that's why it's false, right? But if we put the brackets like this, then it should work, right? Because this is 2 to the power 0.5. So that's square root 2. And then we raise that to the power 2. So that's square root 2 to the power 2. If you remember your maths from school, that is 2, right? So this should be true, right? But again, because of the fact that you have the 0.5, this is now floating point calculation. And floating point calculation can be imprecise. So if you try this out in the REPL, you will find that it's not 2. It's 2.00004. And because of that, it's not equal to 2. Okay, so this is the danger of dealing with floating point numbers. They introduce small errors. This is very close to 2, but it's not equal to 2. And that's the problem, right? And it's not equal to 2.0 either. 2.0 is exactly 2.0. It's not 2.00004. So these options are not correct. So the answer is none of these, right? Now this one I'm less surprised that GPT-5 got wrong, right? Um, if you had asked GPT-5 to use tools to solve it, it can actually call a little Python interpreter and like a REPL and check it out. So maybe you can ask it to use tools to answer these questions, and then it might do better on questions 11 and 15. Okay. The great questions, right? So I hope that review of the quiz was helpful. And I hope you found the quiz itself useful, right? Again, please keep in mind the important thing is not the score that you got out of it. It is what you learned by doing the quiz, right? So if you got a perfect score on the quiz the first time, wonderful, right? Great, you know your stuff. If you got a less than perfect score on the quiz, I would say you are in a better position than the first student because you have an opportunity to learn something. My worry for the first student who got everything right the first time, I'm worried they'll think, this is easy. I know all this stuff, right? They might get overconfident, right? Somebody who got less than a perfect score has an opportunity to learn, right? Again, I'm not saying anything bad about the first student. Congratulations, you really know your stuff well. But please don't get overconfident. And there's always an opportunity for all of us to learn all of the time, right? Okay. Um, okay. So let's see. So there's a question about Yukti wants to know, is this a course enough to learn basics of GenAI? No, Yukti, this is not a course about basics of GenAI. This is a course of basics of programming, but we will use GenAI, right? So the course is programming with GenAI. The emphasis on programming, right? Okay. Pratibha wants to know a question about LaTeX. I won't get to that. The question is, I want to know about is the final exam going to be computer based? So yeah, I mean, I think all your NPTEL exams are computer based, but there are MCQs and short answer type of questions. Some questions will involve programming. So I will give you some more guidance on the exam later on. Okay. So in the forum. Okay. Okay. We don't have too much time left because we had a lot of questions, which is great. But I want to make sure we are clear about assignment statements. That's what we have for this week. Please review the three examples that are given in the video about assignment statements, right? This particular one is super important, right? So this is example one, example two, example three. Please make sure you are clear about how assignments work, right? So I'm not going to repeat what is there in the slides, but I want to just highlight for your attention this slide. If you can understand this slide, it's very important. Now, I know some of you understand the concept of assignments, and this is very easy. Great, lucky you, wonderful. But I'm worried about all of us who are seeing this for the first time. It's very, very, very important that you understand this concept well, right? Please do ask your questions. I'm sure the TAs will be there to help you, right? If anything is unclear, don't feel shy to ask. Please use the Python tutor links that are given to go back and forth. Don't just blindly click next, 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 and say, yeah, that makes sense, that makes sense, that makes sense, right? Go back, make sure you understand it correctly. Change the code, change it to something slightly different. See if that makes sense, right? So again, I'm not repeating all this stuff because that's there in the slides. Here, I just again flagging for your attention. There were some misconceptions about assignment statements that some students have, and this particular one I really want to flag because many of us have this misconception. I said x equal to 25 floor division 2, then I said y equal to x. So in my mind, I think, okay, x and y are linked, they're connected to each other. No, they're just two variables that happen to be labeling the same object, right? So just because x and y are pointing to the same object doesn't mean that when I change x, y also automatically changes, right? And again, I hope the animation that is there in the lecture slides makes it clear. Here I have x and y labeling the same object. Now I create this new floating point object, 25. true division 2. And now when I'm saying x is equal to that, I'm just simply moving this label from here. I'm just moving it yahan pe. I'm moving it here, and that is all that's happening. It is not linked. So y is still touching that floating point object. It is not, just because I moved x doesn't mean I'm forced to move y. So that was the most important point over there, right? Okay. So Nitish wants to know, can we use the same variable 2 times? So Nitish, as this example shows, you can, right? But you can't. I mean, once you use it 2 times, like here I'm using x is this and x is this. Now x is the 12.5. It's no longer the integer 12, right? So x has moved here. So in this sense, you can use it more than once. Okay, so I think that's all we have time for. Next week we are going to be discussing these functions. We'll be writing our own functions. This is some material about some of the built-in functions, like the length function and the max function and the odd function and so on, right? So this is this mathematical notion of functions. But we will write our own functions next time. Okay. All right. So officially we are out of time. I will stop here, but I can wait a few minutes and answer any other questions that we might have. Please feel free to ask on the chat. But officially we are done. Thank you so much. Okay. Any other questions? Okay, if there are no more questions, then we will end. And oh, hang on, there was a question. Nirmal wants to know how to check test cases for AI generated code. Okay, Nirmal, that's a super important question. And uh, Nirmal and I are also in touch over email. But this is also a question, Nirmal, that we will discuss later in the course, right? AI generated test cases can be done. Sometimes those test cases are incorrect, right? So how to check test cases for AI generated code is a very important question. It's a skill that we have to develop. Okay. Okay, Dr. Rajkumar wants to know, are there any prescribed textbooks for this course? No, there are great textbooks on programming, but I'm not prescribing anything. I'm giving you all the materials that you will need as far as this course is concerned through NPTEL itself, right? Okay, so let's see. There are many questions that I couldn't get to. All the best. So we will see you next week. Okay. Um, uh, uh, Someone wants to know about helping with setting up environment variable in Python. So this again, if you can post on the forum, I'm sure someone can give you help there, right? Okay, let's end here. Thank you.